Hello, we are going to continue working with rates today. We're going to be looking at the different ways that we might see rates presented to us. One way is to have rates in a table. So notice, for example, we have a table here that is showing the cost of turf per square feet. So for those of you that are into sports and like playing on turf fields, this is some information that is showing the comparison between the cost and the square feet. Notice that we have different comparisons in the chart. All of these are going to be the same rate, so we may choose any of these if we want to find our unit rate, which is going to be the dollars or the cost per square foot. So I'm looking at all four. I can choose any of these. I think I'll choose the second one here. Remember, we're going to be writing our rates in fraction form. Notice it says dollars first and then square feet second. So in my chart, I want to make sure I'm looking at the cost first, the dollars, and I'm going to choose this one here. So I will use 400. So writing that in fraction form, I have $400. And then square feet, notice in my chart, it's 100. So 100 square feet.
Now remember that when we are figuring a unit rate, we want the denominator or the bottom number to be equal to 1. So we want to know per square foot, what will the cost be? So if you remember to do that, we are going to divide both the numerator and the denominator by 100. Now, that is going to mean that 400 divided by 100 is going to equal 4. 100, and then $4, thank you. And then 100 divided by 100 is going to mean 1 square foot. So we can recognize then that the cost per 1 square foot is going to be $4. Rates can also show up in word problems, and so we have an example for you here. This word problem reads, at 1 p.m. you have 24 megabytes of a movie. So you must be downloading or uploading a movie or whatever that is. And then at 1:15 p.m. you have 96 megabytes of that same movie. So you are trying to find the download rate in megabytes per minute. Remember that when you are dealing with rates, you are dealing with two different kinds of measure. So we are measuring megabytes and we are measuring time. All right, so if we, go ahead.
I'm going to write in words first what we have. So we have our megabytes and then we have our minutes. Now if I look up into our information, I notice that I already have 24 megabytes. And I am going to need to increase that to 26. So I'm going to have to find the difference between those two. So I'm going to write 96 minus my 24.
I'm also noticing that as you're working that out, the minutes kind of have the same situation. Here at 24 megabytes, we have 1 o'clock p.m. And when we're at 96 megabytes, it's 1:15 p.m. And so if we want to figure out the number of minutes, we're going to have to do the same thing. So at 96, it's 1:15. And at 24, it's 1 o'clock. And so the difference in time would be a total of 15 minutes. Now we have our two numbers. Remember, ratio is two numbers that we can use to find the unit rate.
So I'm going to be dividing by 15, dividing by 15, and remember that we can use our calculators when we are dividing here. So of course 15 divided by 15, I have my 1 minute. And I have 72 divided by 15,
which is going to be 4 8/10, or 4.8 megabytes.
So the question said, what is the download rate in megabytes per minute? So my computer can download 4 8/10 megabytes every minute.
All right. Another way that we can see rates demonstrated is in a graph. Let's take a look at this graph that we have here that is titled the walking rate. You will notice that we have two pieces of information on our graph. We have our x-axis that goes across here that shows us we are dealing with time measured in seconds. And you can see that we have intervals of 1. In our y-axis going up and down or vertically, you can see that we are measuring distance in feet. You can see here that our intervals go up by 5s.
We have 2 points that I located on our graph, and then we have an arrow showing what our walking rate looks like here. The first question we have asks that question, 2, 11, that ordered pair, what do those numbers represent? So remember, we're going to look at each of these axes, and that will tell us what that information represents. So the first number 2 down here represents the second, so that means 2 seconds. And the second number 11 is my y-axis. I go over here, and that's my distance in feet, so that's 11 feet. So that represents 2 seconds and 11 feet.
The second question asks, what is the unit rate in feet per second? So I really have to pay attention to the order when they're asking me for unit rate so that I know when I'm representing it that I put the 11 feet first as my first number, then my division bar, and my time, or 2 seconds, second. Ha. To get a unit rate, we know that we divide both numbers by the denominator, so that would be 2. I happen to know that half of 11 is 5.5. And so we're going to make sure we label that feet. So we know that the unit rate for walking here is we can cover 5.5 feet for every 1 second.
The last question says, because it's not on our graph, what if you walked for 12 seconds? Our graph only goes up to 6 seconds. Well, we could go back to our unit rate because we know how far we walk in 1 second. Well, if we multiply by 12, we'll know how far we walk in 12 seconds. So I'm going to take my 5.5, and I'm going to be multiplying that by 12.
And that equals 66. 66 what? Well, we're looking for the distance, and we know that our distance is measured in feet. So in 12 seconds, we can determine how many feet we'll go. So notice how the unit rate can actually be applied to answering other mathematical problems. If you wanted to know how far you could go in a minute, for example, that would be 60 seconds. So we could apply that as well.